Buenos días a todos y a todas. Quiero agradecer a MERIC la invitación. Es un placer estar aquí. Voy a continuar en inglés. So these are the topics that I will address today. I will speak about the offshore wind energy growth in Europe. I will mention the European Union strategy and goals and why going to floating offshore wind. I will show some floating offshore wind flagship projects, briefly touch on the innovations in technology and the levelized cost of energy, present what are the challenges and the opportunities in this sector, and then move to Portugal, how we are progressing on floating wind. Not less important, the coexistence with marine life, and then finalize with the International Energy Agency, the Ocean Energy Systems Technology Collaboration Program, giving their perspective in this field. So you can see here in this plot how offshore wind energy in Europe is growing over the past 10 years. So from 2014 to now, so from nearly 10 gigawatts cumulative installed capacity to 35 gigawatts. And you see in each year that is the installed capacity is ranging between 1.5 gigawatts to 3.5 gigawatts, and the leading countries are UK, Germany, Netherlands, Denmark, and Belgium. So we are, this is where we are today in Europe, 35 gigawatts connected to the grid in 13 countries, over 6,000 turbines, and 136 wind farms connected to the grid. These 35 gigawatts in Europe represents half of what is installed globally, the other projects in Asia. At the European Union, it is recognized the potential and the importance of developing marine renewable energies. And it was launched a strategy for offshore wind, wave, and tidal energy, recognizing that they are essential for meeting the future energy demands on a sustainable way. And in 2020, when this was published, the capacity on offshore wind was 12 gigawatts, and it was set targets for 2030 of at least 6 gigawatts for offshore wind, and here floating and fixed. 1 gigawatt for ocean energy, so wave and tidal. And for 2050, 300 gigawatts for offshore wind and 40 gigawatts for ocean energy. And the member states were requested to integrate offshore renewable energy development objectives in their national maritime special plans, which is what has been happening these last years. 3 years after, so in a response to urgent needs for faster deployment, it was published the European Wind Power Action Plan. And this plan encourages the member states to focus on 6 areas, and I will just highlight here skills. Skills is very important to developing this sector. And why going for floating offshore wind? In the first plot on the left, you see the bathymetry, and in the North Sea in yellow up to 50 meters water depth, and we see that this depth occurs in the North Sea, and it's where fixed button offshore wind projects have been developed. But 80% of offshore wind potential is in waters deeper than 60 meters depth. So available areas for fixed offshore wind become scarce, and in some countries floating wind is the most viable option. So in the third plot you see where the floating projects are being planned. So in many countries, so floating offshore wind opens the possibility for new markets. How the technology is progressing to deeper waters. So in shallow waters, less than 30 meters, we have the monopile structures. Moving to waters between 30 and 60 meters, we have jackets. And when going to a deep, further from 60 meters, we go for floating platforms. And there are mainly three types: the spar buoy, the semi-submersible, and the dash and leg platforms. Of course, increasing water depths, it brings challenges, technical and economic challenge, but average wind speeds are higher and more consistent further from shore. So this means increasing the possibility of increasing energy production potential and also reducing visual and environmental impacts. So these are the four flagship projects in Europe that I would like to show. Windfloat Atlantic 25 megawatt in Portugal, High Wind Tappan 88 megawatts in Norway, and in Scotland, High Wind Scotland in Kincardine 30 megawatts in 49 megawatts. So also there are other small demonstrators in France, Spain, Norway, in Sweden, totally 8 megawatts. So we have 207 megawatts nearly operational on floating wind in Europe, and 90 megawatts under construction. Just very briefly to show a picture of the High Wind Scotland. It was the world's first floating wind farm in operation since 2017, using the technology spar buoy. It has 5 turbines of 6 megawatts, distant 30 kilometers from the coast, in the water depths around 100 meters. And in Kincardine floating offshore wind farm, it's the project that uses the biggest turbines in Europe, 90.5 megawatts, 5 turbines, with a distance of 15 kilometers from the coast. And here's the Windfloat Atlantic, a 25 megawatts project. It was the first project built in the Atlantic. It uses a semi-submersible from the North American company Principal Power, 3 turbines of 8.4 megawatts in waters of 20-25 kilometers distance from the coast, and 100 meters water depth. There are other innovative designs being tested in test sites. So several European countries have developed test sites to test their new designs. FloatGem in the SEMREV test site in France, Demosat in BMAP test site in Spain, Tetraspar in Metacenter test site in Norway, and Sitwirl in Lightskill test site in Sweden, and X1 Wind in Plockan test site. And we will have today in this session a presentation about this project. So all these developments are supported have a strong support of R&D. I think it's also interesting just to look to the pipeline very quickly, because we are talking on floating wind of megawatts, in the range of megawatts. But we see here that these projects are operational mainly in Europe, but other construction in Asia. And when we move to the status of thinking about what projects are under permitting or site control or in the planning phase, we go to the order of gigawatts. So 20 gigawatts in the permitting and site control, 80 gigawatts in the planning phase. So a global pipeline of 100 gigawatts, and new players, so USA and Oceania. Turbine sizes are dramatically increasing. In 2010, we had 3 megawatts turbines, and now the size has reached 15 and 16 megawatts on a global scale. So, and there is a consensus that it will not stop here. Let's look to the levelized cost of ocean energy, levelized cost of ocean energy in floating wind. So in Europe, for pre-commercial projects, it's in the range of 180 to 100 euros per megawatt hour. The industry expects that for the first scale commercial projects, it will be in the range of 80, 100 euros per megawatt hour. And the Wind Europe Association estimates that this will drop to 53, 76 euros per megawatt hour by 2030, which is less than half of what is today. And this will require at least 7 gigawatts of operational capacity. Where are cost reduction expected? It is expected with advancements in materials, in floater and mooring systems designs, in production and assembly processes, and industrialization and standardization. There are a set of recommendations for governments for floating wind farms development that was published by the Wind Europe Association, encouraging to look for specific zones for floating offshore wind, start with the stakeholder engagement earlier as possible, look for the coexistence of floating offshore wind with other economic activities. Also very important to have a one-stop shop, one single entity for licensing. Looking for specific auctions for floating offshore wind projects and defining timelines, criteria, remuneration schemes. Also defining roles and responsibilities for the grid connection, which is a critical issue, and facilitating industrialization of the supply chain. And this is the challenge that we see for floating offshore wind moving ahead. Increasing the size of the turbines, this means stronger foundations and platforms, so and it means increasing demands on materials and space. Updates on ports. Most European ports are not ready to handle floating offshore wind operations. Long distance to shore and limited grid capacity, so grid connection an issue. Mooring and cable solutions, they will require cost reduction, so R&D in these areas. Floating platforms increase loads on cables, so a challenge on the electric infrastructure. And also growing turbine sizes challenge the availability of suitable vessels. The supply chain is really important to have a clear understanding of the whole process, from development to fabrication and construction, installation, operation and maintenance, and decommissioning, and important to mapping the supply chain, identifying all the key components. Also important to access the industry capacity and highlight the gaps. And we are looking for turbine, electrical equipments, moorings, platform, cables, substation, whole part of the supply chain. So important to address the critical bottlenecks and looking, for instance, for skilled workforce or specialized vessels. Ports can become a critical hubs for floating offshore wind. There is an opportunity for ports. The ports will provide support for construction, transport, installation of large turbines. They will provide critical infrastructure and service for the operation and maintenance. There are also related industry like specialized vessels and equipment, skilled labor. So ports can become, in this way, important offshore wind hubs, attracting investment, creating jobs. Now let's look to floating wind in Portugal. We started in Portugal with a pilot project of 2 megawatts in a test site. This was an initiative promoted by the electrical utility in Portugal, EDP, and WavEC was asked 4 years before of this deployment, to explore the potential for offshore wind in Portugal, where at that time there was no discussion, or it was not seen that that offshore wind could be a possibility. But floating wind indeed gave the opportunity to discuss this possibility. So this has been a successful project that ran for 5 years as a pilot project, generating over 7 gigawatts per hour. And the next phase was indeed the construction and deployment of the Wind Float Atlantic, 25 megawatts further to the north. It was the first project in Atlantic, as I said before, and it was developed by a joint venture between EDP and ENGIE, also Repsol and Principal Power, the developer. And it became operational in 2020. So the next step in Portugal, how did we move forward? Very recently, we revised the National Plan for Energy with targets for 2030, and the offshore wind capacity the target was increased to 2 gigawatts by 2030, with a long-term goal of 10 gigawatts. This was in continuation or in parallel with this setting up these targets. The government created 3 working groups to look for the lease areas, so thinking about auctions for the electrical infrastructure and for the port infrastructure. There was a call for expressions of interest, which attracted 50 companies. And there was also a public consultation during this year for the allocation of offshore renewable energy areas. And this map on the right is what it shows the areas that were allocated for the global, for the 10 gigawatts. And we will start now in early next year with an auction for the 2 gigawatts. So, offshore wind in Portugal, what are the challenges that we will face? This has been already, has been the conclusions of these 3 working groups. And we will need for investment in port infrastructure. We will need the expansion of our maritime industry capacity. So enhancing shipbuildings and the logistics industries in Portugal. Due to the early development stage of floating offshore wind, there is a demanding significant economic planning and investment, the need for coordination among all stakeholders, and also specialized workforce training and industry with academia partnerships. Just very briefly to touch on the environmental issues. Here I would like to mention nature inclusive designs, which has been investigated by several groups at European countries. I think it's also an interesting R&D line for a center like MERIC. So it's turning marine infrastructures into beneficial elements of the marine environment, also add innovation in moorings and foundations, and choosing more sustainable materials. And this is also a task in which WavEC has been working recently. And finally, I would like to give here the IEA OES perspective. IEA OES, Ocean Energy Systems, is a group within the International Energy Agency that looks for ocean energy, for wave, tidal range, tidal and ocean currents, thermal energy, salinity gradients. It's a group of 28 countries. And during this year, we have produced an international roadmap how to develop 300 gigawatts of ocean energy by 2050. What are the priorities or the actions to achieve this ambitious target? There are a number of wave and tidal energy technologies at different degrees of development and maturity. Some are already very advanced, and others are operating worldwide, and others are still at R&D level. And what the IEA OES emphasizes is that the potential of all these technologies to work alongside offshore wind to create a more resilient, reliable, and diversified renewable energy mix. So we see here much opportunities for synergies, for exploring the synergies between floating wind and all these ocean energy technologies that are in early stage of maturity, but progressing quickly in very other countries. And finally, just to mention a project, it's a project involving 17 countries from Europe, looking also to this topic, how to address the complementarity in energy systems. And they come to the conclusion that ocean energy, and here wave and floating solar, can balance and support floating wind installations. And this will lead to a more consistent energy output, addressing intermittency. There are also cost reduction opportunities, shared infrastructure such as operation and maintenance, and supply chain optimization. And I leave you with my final message. I think I already end up my time. Muchas gracias.
Bueno, vamos a dejar 2 preguntas para el público. Sí.
Thank you very much, Hannah. And what is the importance of having a test site and to carry out a pilot project?
I think it's very important, and in Portugal, we have a pilot test site that has been used by different technologies, wave energy technologies, and also floating offshore wind. And I think that for advancing in this sector, where there are many unknowns and topics that require in-depth research, like strategies for deploying the technologies, or operation and in maintenance, moorings, all these aspects can be tested in the controlled environment before going to the full or to a more ambitious area. We have in Portugal, we have one test site. The government also created technology-free zone, which is an area where to test innovation. And not just, there are many other things that can be tested in these areas, like all equipments or monitoring systems. So there are much benefits of developing a test site in a country. And what we see in Europe, it's that many countries took this approach, and we were involved in one. It was called Blue, it was a European funded project to have a collaboration with all test sites and share best practice, strategies, and also environmental data. That is it's a good possibility in these areas to collect. There is indeed, it is important to collect much data as possible for informing regulators about or in the public in general. So I just see benefits in developing a test site. Thank you.
Thank you very much, Anna, for these excellent comments about this energy. I would like to know, maybe you or maybe Mr. Eduardo Acuña, why is Chile not participating in this 21 countries member club in this such important technologies? I don't know who is able to answer my question.
I can launch here the invitation. I will be very glad to have Chile as a member of the OES. But I can say it is a very interesting group because the representation in this group is it comes from the government. And it is the government that nominates an entity to represent their country. For instance, an institution center like MERIC will be much appropriate to join this group. In this group, there is a very diversified representation of entities. They come from the government, they come from energy agencies, universities, research centers. So there is a very broad perspective of what is happening around the world on ocean energy, and much information is shared with this group. And also we have the perception that we can only move forward in this with these emerging technologies if we share our lessons and if we collaborate. So collaboration is the key word, I would say, for this sector.
Le damos las gracias a Ana. Muchas gracias, Ana. Muchas gracias por compartirnos la experiencia de Europa, de Portugal, y que ha sido súper valiosa también para lo que podamos llegar a replicar en Chile.